Welcome back to Logistic Regression Demo using SPSS 15. This is part 2, so I'll be examining the output from the syntax we previously entered. So we'll take you right to that syntax. This is what we had entered before. What I did change was just going ahead and using the interaction syntax built into the Logistic Regression program. And then you can run that using the arrow key. What you get up at the top here is just the syntax that it ran, so you can double check that if you want. You also receive a case processing summary, so you can analyze whether or not you need to do any missing data analyses or how much of your data was excluded from the current analysis. In this case, we have no missing cases, so that's good. And you can also see here how your dependent variable and your categorical variables in your predictor model were coded. And it's a good idea to just double check that and be sure it was coded the way you thought it was for ease of interpretation. Otherwise it can be confusing. And then we have block 0, which is it's called the beginning block. This is really the constant only or reduced model. And it's good to look at a few things because this model kind of sets the stage for the comparison of our full models. And what we have here in the classification table, first of all, is our observed versus predicted values, and using just the constant and based on the overall sway of our data, the model was just guessing that everyone did not attend treatment, and it was right 65.4% of the time. So we want to see what how our model can increase this correct percentage and differentiate between these two sides of the coin, basically. So how much our model can add to that. And the next block that we have here is really kind of looking at what our initial predictors, so our two predictors, gender and center and motivation, add above and beyond the constant only model. And you can see here that this step is significant and the block is significant, which basically just implies that that's really going to also serve our model. That's why these are all the same, because this is our first step. And steps after this time, we're really going to be looking at whether the step was significant in addition to the overall model score. But for this first step, they should all be the same. What we have here is our -2 times the log likelihood. So this is going to be comparing the log likelihood of our current fuller model with our reduced model. And these are our pseudo R-squared. We really want to be careful in interpreting the pseudo R-squared. They are not to be interpreted like typical R-square values that you get in an OLS regression, because this model obviously doesn't fit the assumptions of a general linear model. These were just approximations to the R-squared statistic that were created by statisticians just to have sort of that kind of parallel statistic to an R-squared, but they are typically pretty inconsistent with each other and often either overestimate or underestimate what an actual R-squared would tell us about the model. So these are to be interpreted with caution, although sometimes certain journal editors would like you to report them. Now we're getting into really how to look at the goodness of fit of this model. This is a Hosmer and Lemichaud test, which is probably one of the most used goodness of fit tests for these kinds of models, although they do have their detracting points as well. So what it basically does is it divides up our probabilities in our data set. Our probabilities can range from 0 probability to 100%. And the 0 is going to be more towards the end of did not attend treatment, because that's our 0 value. And then 100, or this is covering our 10th decile from 90% to 100%, is going to be closer to our attending treatment. So what we really want to see is the people who did not attend treatment actually get probabilities that are on the lower end, closer to the 0. And we want people who did attend treatment to get scores that are closer to the 100% end. And obviously each decile represents 10 points. So if that's the case and you have a pretty good fitting model, you're going to have a non-significant Hosmer and Lemichaud test, because it's going to be looking at the difference between the observed number of people who fall into that particular category and the expected. So we have definitely a pretty decent goodness of fit to start out with. Next we have our classification table, and if you can remember our classification table from before, I believe we had 65.4% correctly identified as in the did not attend treatment category, obviously. And this time around, we have 80.4%. So our percentage correct did improve with the addition of our two predictors, gender and center motivation. So that's a good sign. And what you can see here is that really the model is starting to differentiate between people who did not attend treatment and people who did. So that's obviously really good. And what we want to see is really heavy scores here, and very light scores here, because those are going to represent our incorrect classifications. And now we have our parameters table. So this is going to list our different predictors here and our constant down at the bottom. And the first step here is our raw coefficient in the model. Then we have the standard error for that raw coefficient. And the wald test, which is sort of like a z-test or a t-test that we typically see in the OLS regression estimation. And this will tell us whether or not these particular predictors were significant predictors in our overall model. And here, the EXPB is really just saying exponentiated raw coefficient. So this is going to be our more interpretable odds ratio that we've come to depend on. And with an odds ratio, what's important to remember is scores between 0 and 1 are going to indicate an inverse relationship between the predictor and the outcome variable. Scores right at 1 are really going to indicate no real relationship between the predictors and the outcome. And then scores above 1 are going to indicate a positive relationship between the predictor and the outcome. So here what we can see is because we know that this particular variable is the reference group is women and the primary group is men, we know that men tend to show lower probability or lower odds of attending treatment. And this is our 95% confidence interval for those odds ratios. And for motivation, on the other hand, which is also a significant predictor, it tends to be that people, for each 1 point increase on your centered motivation score, your odds of attending treatment go up by 4.691 times. So that is actually pretty good, although what you always need to consider in interpreting the odds ratios are really the scaling of the measure at hand, because remember, unlike with OLS regression, this is really for each 1 point increase on the scale. Next we have the classification chart. So this will show us how our cases were classified, and what we really want is the D's here are the did not attend treatment people, and the A's are the attended treatment people. We really want the D's to pile up close to 0, because if they did not attend treatment, they should be a 0 in the observed data. So we want them to pile up here, and we want the A's to pile up closer to the 1. What you can see here is it's really kind of splitting well, that the D's tend to be piling up nicely at the 0 end. The A's are a little bit more distributed throughout, although we do have some more A's kind of collected towards this end, which is a good thing. So maybe we can improve upon this model, is kind of what this is initially telling me. And in order to interpret block 2, I'm going to go ahead and do a third part of this demonstration, and I will see you back here in just a bit.